Alright guys, we are looking today at inequalities. It's very, very similar to equations with just a couple of easy changes for you to make. You're just going to have to pay real close attention to what we're doing. Let me go ahead and get you caught up. I want to show you a shot of our journal table of contents. Right here, inequalities should be on page 25. What we're about to do should go to page 25 in your journal, okay? So you can pause the screencast right there, get caught up if you need to. Be quick about it. Alright, now, your inequality notes, I'm going to let you pause the screencast. I'm going to read through this once or twice, and then I'm going to let you pause the screencast and make sure you have it written down. Alright, an inequality is a comparison of two numbers or expressions that are not equal. Hence the word in. The prefix in means not. Okay, and then you have your root word equal. And the ity, the state of being, I think. But it's a comparison of two numbers or expressions that are not equal. Use greater than or less than symbols. Okay? Now, you can pause that, make sure your definition is written down, and then come back to it. Alright. And inequality uses one of the following four symbols. Okay, this symbol right here, it points to the left. Notice this, it's like an arrowhead that's pointing down to the left on your number line, and the numbers on the number line that are towards the left are less than. So this is less than. Okay? The next one is greater than. If it points up on the number line, it's pointing to the numbers that are greater. That's greater than. Alright, this is, when it has the little bar up underneath there, that's an equal to bar. It's a blend of greater than and the equal to symbol. So this is greater than or equal. This is less than or equal to, sorry. Less than or equal to. And the next one is greater than or equal to. Okay? So there's a place where you can come back and get your symbols. I also want to include right here, you will remember when we graphed these, when you graphed these in 6th grade, you should remember that you used, look at these dots, look at these graphs down here, you used closed dots in some cases and open dots in other cases. Alright, and what makes the difference in whether or not you use a closed or an open dot when you're graphing these is your symbol. If it doesn't include the equal to bar, it's an open dot, okay? Whether it's going to the left or to the right, if you don't have an equal to bar under here, that's an open dot. Alright, now if you put the equal to bar there, regardless of which way it's pointing, that means to close the dot. We'll talk a little bit more about that in just a second when we're graphing. But again, this is some review from 6th grade here for you. Alright, now we've got a chart here that's going to compare how you say it in words, and how you write it using symbols, and then how you graph it, and then what are the possible solutions. Okay? Alright, so starting with the first one. X is greater than -1. Okay? In symbols, that would be, we would say X, the greater than symbol points to the right, -1. Okay, X is greater than -1. Alright, so this, because it doesn't have an equal to bar, remember, if it doesn't have an equal to bar, it's going to be an open dot. We're going to put an open dot at -1, and we're going to shade in the direction that it's pointing. Okay, this thing points to the right. All right, circle the point. All right, see that point right there? The point's to the right. So you're going to shade to the right. You make your shading nice and neat for me, guys. Take a little bit of pride in your graphs. I don't require perfection at all, but I do just want you to do your best. Okay, I see some kids make some sloppy graphs, just slop some stuff down that's not very pretty. Alright, now, possible solutions. The first thing I want to talk with you about in this one is that -1 is not part of this solution set. Okay, we're talking about a group of numbers. It's like me saying I have greater than -$1 in my pocket. I couldn't have -$1 anyway. But if I have greater than something, that means I don't have that. I have more than that. So when I say I have greater than -1, that means anything above -1 is fine, but -1 is not. Okay, so you can't include -1 as part of that solution set. The solution set lies on your black bar. Okay, it could be 0, it could be 1, it could be 2, it could be anything above that. Okay. All right, now this one uses the algebraic symbols, and we're going to go write it in words. Okay, so you would read this M, and this symbol is pointing to the left, so it says less than -2. So you would write M is less than -2. Okay, M is less than -2. All right, now the way I would graph that is I would go to the -2 on my number line, and I would put an open dot or a closed dot. Well, this one does not have an equal to bar up under it, so I'm using an open dot at -2, and I'm going to shade the direction it's pointing. Look at the point. The point of your arrow is to the left, so you shade in this direction. Alright, next. Ooh, this time I have a graph. Alright, I'm going to let you use your favorite variable. I don't care. I'm going to use M for Monica. I don't care what variable you use. It doesn't matter. Alright, so M. Now, the one thing I notice about this graph is that it is shaded in. Okay, and if it's shaded in, that means it's going to have an equal to bar up under it. Okay, and the arrow is shaded to the right. It's shaded the numbers greater than where we started. So this is greater than or equal to. Okay, M is greater than or equal to what number? 0. All right, and then you just write what you said. M is greater than or equal to 0. Sorry, my writing is horrible right there. M is greater than or equal to 0. Now, I didn't get possible solutions. I'm sorry. Possible solutions for this one up here, go to your black arrow. Can you include -2? Absolutely not. It's not shaded. But -3, -4, -5, any of those are possible solutions. Anything bigger than that you give. Alright. Now, right here, possible solutions, guess what? Because this is shaded in, I can include 0 as a possible solution, and then 1 and 2 and 3, and I mean so on. It keeps going forever. You got infinite possible solutions there. Alright. This one says, alright, G is, this symbol is pointing to the right, so it's greater than, and it has an equal to bar under there, so greater than or equal to -1. So we say G is greater than or equal to -1. All right, now, so we're going to find the -1 on our number line, and we're going to decide what kind of dot goes there, an open dot or a closed dot. All right, we have an equal to bar, and if you look up here, if you have an equal to bar with it, you close the dot. All right, so you're going to put a closed dot at -1, and we're going to shade. Which direction is it pointing? Find the point on your arrow. It's pointing to the right. We're going to the right. Next, we have. I'm going to use M again for Monica. I don't care what variable you use. All right, now it's definitely going to be less than because this is shaded to the left. But is it going to have an equal to bar? Well, if you notice your dot is open, and open dots do not have an equal to bar, so we just say M is less than, what number? 1. So M is less than 1 is the way that should look. I forgot possible solutions in both of them. Alright, possible solutions. I'm going to make sure on this one that because this dot is shaded in at -1 is part of the solution set. -1, 0, and 1. Alright, here we've got, I can't include the 1 because it's not shaded in. But anything else? How about 0? How about -1 and -2? Any of those are fine. Okay? Anything on your bar is a solution. Okay? Alright, now, solving inequalities. To solve an inequality, you undo what has been done to the variable, just like equations. There's going to be a couple of changes I'm going to talk with you about in a couple of minutes, but this one is extremely simple. Alright, first thing we're going to do is make sure the variable is on the left-hand side. Here's my divider. All right, the equal to sign is my divider. Variables on the left, variables on the left, variables on the left. I'm good to go. We'll do some changes with that in a minute on some different ones. But in this case, my variable's on the left-hand side like it ought to be. All right, so just like I'm going to solve an equation, I see adding 5, so I would subtract 5 from the left, and I would subtract 5 from the right, and I end up with a 0 pair right there. This looks very familiar, doesn't it? F is, bring your sign down, less than or equal to. Please keep this an inequality sign. Don't change it to an equal sign. It's not an equation. All right, and 7 minus 5 is 2. All right, let's solve all of them, and we'll graph all of them, okay? All right, m is divided by 3 is greater than or equal to -2. The inverse of division is multiplication, so we're going to multiply by 3 on the left and multiply by 3 on the right. This is simple solving an equation. All right, so m is greater than or equal to -6. Your last one, this is 4d is greater than or is less than -8, so you're going to divide by 4 on the left and divide by 4 on the right, and you have d is less than -2. Okay, we should not have any trouble solving those. Now graphing them. The way that I want you to graph them is, I want you to put the focus point. And what I mean by your focus point is what your graph is going to be. Your graph is going to start with 2, okay, in this one. So I'm going to put a 2 in the middle of my number line as my focus point. That's what I'm saying. Is this is where I'm going to focus. All right, so I'm going to put a 2 right there, and I just want you to go a couple to the right and a couple to the left. Okay, meaning I want you to put a 3 and a 4 on the right, and a 1 and a 0 on the left. And you don't have to keep filling out. I've seen kids make number lines so long and so detailed. It's like, are you kidding me? Just make a number line. All right, I do want you to show me 2 to the right and 2 to the left, and then you can stop. Okay, that's fine. But less than or equal to 2, I'm going to shade at the 2, and I'm going to color it in because I have an equal to sign. So there's a closed dot at 2, and I'm going to shade to the, find your point on your arrow, it goes to the left. Okay, next we have greater than or equal to -6. So I'm going to put the -6, and this is where you better be careful. And your negative region, I always have some kids that number their number line completely wrong. This up here is -5. Not -7, okay? -7 goes this direction, and -8 goes this, -6, -7, -8, -5, -4. Because up here I'm going to have 0. 0 is somewhere up here, right? And I go -1, -2, -3, -4, -5, -6, -7, -8. You better be careful in number. When you're in the negative section, your number line flips around backwards. So if you don't have your number line right, I'm going to count the whole thing wrong, okay? You've got to know how to make your number line. All right, so you've got a closed dot at -6 and shade to the right. All right, lastly, you have a -2 right there. And you're going to put an open dot at -2 and shade to the left because it's less than. All right. Now, I want you to get this paper right here. I'm not going to go over a whole lot of it because this is what you had on your previous sheet. This, pay attention to the direction of the inequality sign. The big alligator eats the big one. Okay, these are your big numbers, these are your small numbers. All right, these are things you can do without affecting the direction of the inequality signs, okay? You can add or subtract numbers from both sides. You can multiply or divide both sides by a positive number, but when you will change the direction of the inequality when you multiply or divide by a negative number. We'll talk about this more in just a couple of minutes, but I want you to look at this one right here. This is a good example. You had -2y is less than -12, and what they had to do to solve was they divided by a negative. So they changed the direction of the inequality. It went from less than to greater than right there. Okay? And when you swap the directions, when you swap the left and right hand sides, you must also change the direction of inequality. Meaning when you put your variable over